Okay, this section will talk about the medium voltage drive, part C. Today is the last day of Chinese New Year. You see the lantern and my beautiful vest, silk vest. Okay, according to the Chinese zodiac, this year is a year of ox. So wish everyone a prosperous new year. So the next VSI, voltage source inverter, medieval drive, we call the 5-level. Okay, this is topology for the 5-level drive. And here is each phase. Each phase we have a cell. The cell including the AC to DC rectifier, DC capacitor, and the inverter. You can see the rectifier use 2 rectifier in series, and here's the neutral point. And for each cell, actually is a NPC topology with the H bridge. That means we have 2 phases. And each phase, you see 4 component, 2 clamp, diode, and the neutral point, plus positive and negative bus. So one phase, each phase, the output is 3 level. So for one cell is 5 level. Each phase is 0 plus minus VDC. So line to line, the output of a cell is 5 level. And for each cell, you have 2 output. So one output of each cell is connected together to form a neutral point. And the other connection of each cell linked to the output of a drive and then to the motor, A phase, B phase, C phase. So that means for each phase, the voltage is 5 level. So we call the 5-level drive. And for the rectifier, like for each cell, you have 2 rectifier. So total, one drive, 6 rectifier to form a 36 pulse rectifier with a very good harmonic performance. So as we said, the drive is a 5-level drive. This is for phase voltage. And for the line-to-line voltage, we have a total of 9 steps, 9 levels. And here is the output voltage and the current of the drive. And this is the example of the 5-level drive. This is the ABB drive, ACS 5000. This is the 9-level drive. You can see the main components and the cooling control. And the last one is we call the cell series multi-level. It's also a VSI. It's multi-level, more than 5 level in a lot of cases. So this is invented by Robicon and later acquired by Siemens. Robicon is the inventor of the topology. So we can see, the cell. Each cell is a VSI inverter, rectifier, DC, and H bridge. And then, the output of the cell is series together, and there was a neutral point, floated neutral point, and then, the other terminal wire to the motor with the produced medium voltage. And for each cell, the feeding by a secondary as a transformer. And the multiple secondary, we have a phase shift to form a multiple rectifier. So this drive will have very good performance on the input harmonic, very low harmonic distortion. And this is the input waveform voltage and current of drive is a very good waveform, close to sinusoidal. Typically for this kind of drive, the total harmonic THD will definitely be less than 5%. In a lot of cases, is maybe 2% or even less, depend on the number of pulses for the rectifier. And this is the output waveform. The output have a multiple level. For example, if one phase we have a 5-cell in series, then each cell, the output voltage will be 1 and plus minus VDC. So 5-cell series will be 1 plus minus 1, 0, plus minus 2. So that means though, if we use the 5 cell in series, the phase voltage will be 11 level. So very good waveform, for the voltage, and even better with the current. So this is the Robicon Perfect time drive, air cooling drive, partial control, partial transformer, and cooling blower top hat. And this another example is a Nanco company. It's a liquid cooled drive with the oil transformer and the medium voltage cell. Use medium voltage IGBT 3.3 kV or 4.5 kV IGBT with a film capacitor. A very good lifetime, not film capacitor, the life is much longer than the electrolytic capacitor. And the maximum we have done for project is the drive is 130 MVA, and the motor driving is 120 megawatt. This is so far the largest drive in the world. Okay, this is for today's tutorial. Thank you.